All right, so the next thing that I want to do in today's class is to introduce you a little bit to algebra tiles. So um, sorry, I'm trying to pull out my algebra tiles, but a few weeks ago, I posted in in one of your modules, in the September 29th module, I posted this little page about getting algebra tiles online, and there's a link here that takes you to that page, right? So it'll take you to this page, and then if you click on this little area, or this little arrow by algebra tiles, then it gives you these algebra tiles. And so you don't have to buy algebra tiles. You can just use this online tool. Now I will warn you that at this point in the course, I'm going to start using some of the videos that I used last semester. So and in those videos I was using actual physical algebra tiles like these, right? So in the videos that you'll see me posting after today, these are the kinds of tiles that you'll see, and you'll see me actually physically manipulating them. But you're welcome to just follow along with what I'm doing using this website. Now, when it comes to homework and tests and quizzes and things like that, if there's some kind of thing that I want you to do with algebra tiles, and then I'll need to be able to see your work. And so what you could do is, I don't know if there's a way to download like images that you put in here. You can kind of play around with it and see if there's a way to do that. But if not, you can just take screenshots of doing your work kind of step by step. So that's one option. But another thing that you could do is to just draw the figures out. And this is something that as we move through the videos, I'll show you how I draw them on a piece of paper. You do have this little edit tool, which I wonder if that allows you to like write stuff. Option, clear tiles, save options. Well, no, I don't think it gives us a way to write. That might be a little bit of a problem. Anyway, so so let's get started and talk about how these algebra tiles work. So you can see the value of the tile is written on the tile. On the physical ones that I have, the value of the tile is actually not written, but you can kind of figure it out because these tiles, they all have a particular length and a particular width. So actually, let me pull out this tile first. Notice that this tile here has the same length as this tile, but it has a different width, right? And then notice I've got a little tiny tile here. Now this has the same width as this tile, but not the same length. So the way that we define these tiles is I'm going to say this smallest square, I'm going to say that it has length and width 1, which means that this little this tile here, this rectangle, it has a width of 1, but its length, I don't know, right? I don't know what its length is. Now, I could try to line up a bunch of 1s to see if it's like equal to 3 or 4 or 5 or something. So if I try to line these up, you'll notice that it doesn't quite work. Like 3 tiles isn't enough. 3 units. So these little 1x1s, I'm going to call those a unit. But these units, 3 units is too short, and 4 units is too long. And so that's done on purpose. That's because we want to leave the length of this tile ambiguous, so that we can treat it like a variable. So we'll just call this variable x. Okay, so we'll call the length of that tile x. Now the value of the tile is the area of the tile. So in this case, a 1x1 tile would have an area of 1. So the value of this tile is 1. And here, the value of the tile would be its area, which is its width times its length. That's 1 times x, which is just x. right? So this is an X tile. And so based on that, you can kind of guess what value this is going to be, because it has the same width as this tile, so that width must be X, but it also has the same length as this tile, so that length is also X. So so if this right here is an X by X tile, then the value of the tile is its area. X times X is X squared. So this is an X squared tile. Okay? And you can see this like in the computer program as well. It's just that I didn't want you to see the labels, because I wanted you to understand where the labels come from. But that's where the labels come from. The label on the tile is actually the area of the tile. Okay? So looking at it here, right, you can tell, okay, so I've got an X squared tile, so it's an X, right? It's the same width, but also if you double click on this, it'll rotate, and then you can see, okay, it's the same length as well. So it's an X by X, so it must be an X squared. Meanwhile, this X is just, it's a unit that way, but this way it's not quite an equal number of units, and again, that's done on purpose so that the length of it is supposed to be ambiguous. So that takes care of like the unit tiles, which are these ones, the X tiles, which are these rectangles, and the X squared tiles, which are these bigger squares. Now in addition to that, you have some other tiles. So you have a Y squared tile, and again, that's not the same size as the X squared tile on purpose. It's also not an equal number of, it's also not like a set number of units, and again, that's also on purpose because we want that length to be kind of ambiguous so that we can treat it like a variable. But the Y tile is the same same width, and if you double click it, it'll rotate. You can see it's the same length. Okay. So this is the Y tile. This is the Y squared tile. And then this is an XY tile. It's an XY tile because its width is X and its length is Y. So the area of the tile is X times Y, or in other words, XY. So the whole point is the area of each of these tiles is the value of the tile itself. So so that's how you deal with that. Now, so you've seen that you can rotate these ones by double clicking. Okay, you can rotate that, I guess, but it's just a square, so it doesn't really rotate. If you single click it, then it turns red and it becomes negative. So all of these tiles could be negative as well if you just click them once. Okay, and then click them once again, and they become their positive selves. And then you've also seen me, like if I want to get rid of a tile, I just drag it over back to where it came from, right over here. And that's how you delete tiles if you don't want tiles on your page anymore. So that's how you take care of these tiles. So hopefully that gives you some idea of how these things work. Now, we've talked about equations, we've talked about expressions. We're going to talk about how to simplify expressions with algebra tiles, and then later on we'll talk about how to solve equations with algebra tiles as well. So so we will be working on both of those different kinds of concepts. For now, another thing that you can do with algebra tiles, though, is you can talk about area and perimeter. And that's what I want to do right now, just by way of sort of introduction, I guess, to algebra tiles. So what I'm going to do is build a figure out here of algebra tiles, and then I want you to pause the video and see if you can find the area and the perimeter of that figure. Okay, so here we go, and I'm just making this up as I go. But let's do that one. So go ahead and pause the video, see if you can find the area and the perimeter of that shape. Okay, while you're doing that, I'm gonna build that shape here with my like actual physical algebra tiles. Okay, so let's look at this together. So this is the shape that I made. Now, as far as the area is concerned, this is pretty easy, right? Because we know that this is an x squared tile, and that means its area is x squared. We know that this is an x tile, and that means its area is x. We know that this is a unit tile, and that means its area is 1. So the area of the figure is x squared plus x plus 1. Okay, so that's not difficult at all. The perimeter tends to be more challenging. So let's talk about the perimeter of this shape. Okay, since this is an x squared tile, that means its length and width are both x. So to get from this corner to this corner, that's a length of x units. And then to get from this corner to this corner, this is 1. From here to here is x. From here to here is 1. From here to here is x. From here to here is a little tricky. Let's come back to it. From here to here is 1. Here to here is 1. Here to here is 1. So now the last little part, we've got to get from this little corner to this corner out here. Well, so here's the trick, right? We know that the entire length from this corner to this corner is x. But from here to here is 1, and that's already accounted for. So from here to here should be x, it should be x minus 1, right? So here is x minus 1, right? That's that little part there. So the reason I'm labeling all the sides is because that's what the perimeter is, right? The perimeter is the distance around the object. So so I'm going to start at this corner, and I'm going to work my way sort of counterclockwise. Okay, so when I add these up, so I'm going to start here and work my way counterclockwise. So it's going to be 1 plus x plus 1, 1 plus x plus 1 plus x plus 1 plus x minus 1 plus 1 plus 1, and then that gets me back to where I started. Okay, now we need to simplify this, so let's collect our like terms. So I've got 1, 2, 3, 2, right, because it's a negative. So 1, 2, 3, 2, 3, 4. 4 units, and then how many x's? 1, 2, 3, 4 x's. So the perimeter is 4x plus 4. Okay, that's the perimeter of that shape. Let me give you an alternate way that you could have thought about this little piece. So instead of labeling it as an x minus 1, and so instead of labeling that as an x minus 1 and labeling that as a 1, you could have just realized that if you add this piece to this piece, then you get this piece, right? Let me do that again. When you add this unit to this little piece right here, from this corner to this corner, well, then you just get this entire length from this corner to that corner, and that length is just x. So you could have just labeled it like this. And then your expression would have been missing an x minus 1, and then it also would have been missing another 1, and it would have just had an x in the place of all of that mess, right? And if you combine your like terms there, you still get 1, 2, 3, 4 units, and 1, 2, 3, 4 x's. So you still would end up at the correct answer. Okay, but there you go. That's the area and perimeter of that particular figure. Let's do another one. I'll just give you one more, and maybe we'll make this one a little more challenging, I suppose. I'll do something like that, and no, like that. How about this? Or maybe I'll rotate it and make it like that and like that. Okay, yeah, let's do that one. See if you can find the area. Oh, actually, here, let me get another one of these guys in there somewhere. There. That's good. Yeah, okay, that's good. See if you can find the area and the perimeter of that shape. I'm gonna build this using my tiles. Okay, if you're not finished yet, give the video a pause and see if you can work it out on your own. But here I go. The area, I think, is pretty straightforward, right? So the area, well, it's a y squared plus an x squared plus an x plus a 1 plus another x. We can simplify that. That's y squared plus x squared plus 2x plus 1. Okay? What about the perimeter, though? Well, so the perimeter, that's the trickier one. But let's see if we can do it. Okay? So from here to here is x. And x and x. How do we get from here to here, though? Well, notice that this is our y squared tile, right? So that means the length of this tile is y. So it's going to be y minus x, right? That's that length right there, y minus x. Then from here to here we've got y. From here to here we've got x. From here to here it's a 1, and then a 1, and then a 1, and then a 1. This part right here is going to be x minus 1, right? So x minus 1. What about this length? Well, the whole length is y, and this little length right here is 1. So this from this corner to this corner should be y minus 1. So that's y minus 1. From here to here it's a 1. From here to here it's an x. From here to here it's a 1. And then this last little segment from here to here, how much is that? Well, this is y, and this is x. So this is y minus x. Okay, so I think I've got everything correctly labeled. So to find the perimeter now, we just need to add all these things up. So I'm gonna start at this corner right here, and I'm gonna work around counterclockwise. So I'm gonna have x plus y minus x. You don't really need the parentheses there. I'm just gonna put them there to emphasize that that was just one of the lengths. And then plus y plus x plus 1 plus 1 plus 1 plus 1 plus x minus 1 plus y minus 1 plus 1 plus x plus 1 plus y minus x plus x, and then I'm back to where I started. Okay? Now let's see if we can combine our like terms. I'm going to collect all of my y's first. So I've got 1, 2, 3, 4. So 4 y's. How many x's? I've got 1, 2, minus 1 is 1, plus 1 is 2, 3, 2, 3. So I think I've got 3 y's, or 3 x's in total. And now for my units, I've got 1, 2, 3, 4, 3, 2, 3, 4. So plus 4. Okay. And that's that one. I think that's enough to sort of get you started thinking about algebra tiles. In the next class, we'll talk about addition and subtraction of algebra tiles. So how to model addition and subtraction with algebra tiles. But that's all I have for today. So you'll have some of these kinds of problems in the homework as well.